Stereochemistry of SN2 reaction. Since carbon-halogen bond in alkyl halides or haloalkanes is polar with negative end on halogen atom. That is, carbon have delta positive and X have delta minus. The nucleophile always approaches carbon atom of carbon halogen bond from a side opposite to halogen atom. Nucleophile have a lone pair electron, so there will be repulsion between negative charge or lone pair electron on a nucleophile with a negative charge, partial negative charge present on halogen atom. In order to avoid such a repulsion, the nucleophile always approaches a carbon atom of a carbon halogen bond from a side opposite to halogen atom. It is called back side or a rear side approach of a nucleophile. Due to this specific backside or a rear side approach of a nucleophile, in the case of optically active haloalkanes, complete inversion in configuration take place. That is, R isomer of alkyl halide give S isomer of substitution product, or S isomer of alkyl halide gives R isomer of substitution product. For example, this formula represents R isomer of 2-chlorobutane. 2-chlorobutane, second carbon atom is asymmetric. It can show geometrical isomerism. Two-chlorobutane contains an asymmetric carbon atom, hence it can show optical isomerism. The second carbon atom is asymmetric. It is a R isomer of 2-chlorobutane. The highest priority group is chlorine, second is ethyl group, third is methyl group. Lowest priority group is pointing away from the observer. So 1, 2, 3 runs in clockwise direction, hence the isomer is R isomer. When it is subjected to nucleophile substitution reaction with aqueous solution of NaOH, this nucleophile approaches carbon atom of carbon chlorine bond from a side opposite to chlorine. Here chlorine is pointing towards the observer, so OH group will approach this carbon atom from the rear side or back side. So the structure of a product will be like this: CH3, CH2, CH3. Chlorine will be replaced by OH minus. OH will be in the rear side. Therefore, hydrogen atom will be pointing towards the observer. This is a S isomer of 2-butanol. OH group approach from the rear side of carbon halogen bond. Hence, OH group in the product will be pointing away from the observer. Therefore, group pointing towards the observer will be hydrogen atom, and this represents S isomer of 2-butanol. In order to find the configuration of this molecule, exchange these groups. On exchanging, we will get CH2, CH3, CH3. Here it is OH and H. Now the priority 1, 2, 3 runs in anti-clockwise direction. So therefore, its configuration is S. That is R isomer of 2-chlorobutane give S isomer of 2-butanol. It is called inversion of configuration. R become S. Configuration is inverted. Similarly, S isomer of alkyl halide gives R isomer of substitution product. For example, CH2, CH3, CH3, bromine, hydrogen. It is a S isomer of 2-bromobutane. 1, 2, 3. Anti-clockwise direction. So it is a S isomer of 2-bromobutane. On treating with aqueous solution of sodium hydroxide, it gives R isomer of 2-butanol. The structural product will be CH2, CH3, carbon, CH3. OH will be pointing away from the observer because OH is approaching this carbon atom from a side opposite to bromine. Here bromine is pointing towards the observer, so OH is approaching this carbon atom from the opposite side, that is from the rear side. So position of OH in the product will be at the rear side, or it is pointing away from the observer. So this bond corresponded to hydrogen atom, that is hydrogen atom is pointing towards the observer. Its configuration is R. It is R isomer of 2-butanol. In order to find the configuration, simply make two mutual interchanges between the groups bonded to asymmetric carbon atom. So you will get an equivalent structure. CH3, CH2, CH3. Here 1, 2, 3 runs in a clockwise direction. So it is a R isomer. That is S isomer of alkyl halide give R isomer of substitution product. It is called inversion of configuration. It was first discovered by Walden during his experiments with enantiomers of 2-chlorooctane. Hence, it is called Walden inversion. Walden carried out experiments with enantiomers R and S enantiomers of 2-chlorooctane and found that SN2 reaction is accompanied by complete inversion of configuration. That is R isomer of alkyl halide give S isomer of substitution product and vice versa. So during a SN2 reaction, complete inversion of configuration take place. If the reactant is a dextroisomer, the product need not be levoisomer because R and S do not correspond to dextro or levo rotatory nature of enantiomer. We can predict only configuration from a given structure. The directional rotation, that is whether it is a dextro or a levo, cannot be predicted from a given structural formula. So dextroisomer in a SN2 reaction gives a product that may be dextrorotatory or levorotatory because the compound is different. Here it is a alkyl halide, here it is a alcohol. So R isomer gives a S isomer. We cannot say dextroisomer gives a levoisomer in all cases. because destro and levo are independent on the configuration. Only configuration changes during a SN2 reaction. S configuration become R, or R configuration become S during SN2 reaction. It is due to the specific backside or rear side approach of nucleophile. If halogen atom is pointing towards the observer, nucleophile approaches from the rear side. If halogen atom is pointing away from the observer, nucleophile approaches from the front side. Whatever be the direction of approach of nucleophile, it is always called rear side approach of nucleophile. Its meaning is nucleophile approaches carbon atom of a carbon halogen bond from a side opposite to halogen atom. This is a tetrahedral molecule. This carbon atom is sp3 hybridized and the groups are oriented tetrahedrally around this carbon atom. So here chlorine is pointing towards the observer. OH comes from the rear side. So position of OH in the product will be pointing away from the observer. That is a dash wedge position. So solid wedge position is occupied by hydrogen atom. Hence R isomer gives S isomer of a substitution product. It is called inversion of configuration. It was first detected by Walden. Hence it is called Walden inversion.